In this problem, we're told that a retail outlet for calculators sells 700 calculators per year. It costs $2 to store one calculator for a year, and when we reorder, there's a fixed cost of $7 plus $2.25 for each calculator. We want to know how many times per year should this store order calculators, and in what lot size in order to minimize inventory costs. So, what are our inventory costs? This is what we're going to minimize, so once we have a formula for inventory cost, we're going to take the derivative. But to get there, we need a formula. So there's the carrying cost, which is the cost of storing these calculators. And there's the restock cost, which is when you order. Okay, so we want to determine how many calculators need to be ordered each time and how many orders there should be. So since we need to sell 700 calculators in a year, maybe I would order 10 calculators, and then the number of orders would be 70. Or maybe I would order 35 calculators, and then I would have 20 orders. So I'm just kind of making up numbers, and I'm trying to make up nice numbers. What I see is that the relationship between the number that I order and the number of orders is that these have to multiply to make 700, so that I have 700 calculators available to sell. So I'm going to call the number of calculators that we are purchasing each time. So let's look at each order. We're going to order X calculators. And then how many orders should there be? There's going to be 700 divided by X orders. That way, X times 700X gives us 700 calculators. All right. So now we're going to look at how does this information relate to our carrying cost and our restock cost. So our carrying cost has to do with how many calculators we have at any given time. And since we're ordering X calculators at a time, we can have anywhere from 0 to X calculators. And so what we're going to do is figure out the average number of calculators we have at any given time by taking 0 plus X and dividing by 2. So this is our number of calculators that we have in stock at any given time, and it costs $2 to store those calculators. So my carrying cost is just X. Now I want to figure out my restock cost. Well, I need to restock 700 over X times a year. So I'm going to start with that. So I'm going to do this 700 over X times, and each time it's going to cost me $7 plus $2.25 per calculator. Okay. So I can simplify this, and that's going to be 4,900 over X plus 1,575, and the X's cancel out there. Okay, so now I've got my carrying cost and my restock cost. So inventory cost is X plus 4,900 over X plus 1,575. And now I'm ready to take the derivative of my inventory cost. Derivative of X is just 1. The derivative of 4,900 over X, if I write this to the side as 4,900 X to the negative 1, the derivative is going to be negative 4,900 X to the negative 2. So I'm going to write minus 4,900 over X squared. And the derivative of 1,575 is 0, so that's done. So now I can minimize my inventory cost by setting the derivative equal to 0. And let's come over here to solve that equation. So if 1 minus 4,900 over X squared is equal to 0, then 1 is equal to 4,900 over X squared, multiply both sides by X squared, and X is equal to plus or minus 70, but obviously we're not ordering negative 70 calculators each time, so it's got to be 70. And if we're ordering 70 calculators, that means there must be 10 orders per year. And that will minimize our carrying cost, or our inventory cost. And that's how you do that problem.